Today we're going to talk about the slope, designated using the letter M, of a line passing through 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. These are what we call subscripts. The first ordered pair is designated x sub 1, y sub 1, and the second ordered pair is designated x sub 2, y sub 2. And the slope, M, is equal to the rise of the run, which is the vertical change over the horizontal change. And of course, the vertical change would be the change in the y's, and the horizontal change would be the change in the axis. That's denoted delta y over delta x. That little triangle is a Greek letter called delta, and it simply means change. So it's the change in the y's divided by the change in the axis. So the way that you find the change in the y's would be simply by subtracting the y coordinates, and likewise the change in the x's you'd find by simply subtracting the x coordinates. So the formula mathematically for computing the slope is y sub 1 minus y sub 2 over x sub 1 minus x sub 2, or equivalently y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You could use either one of those two formulas, you still get the same thing. So again, what we're trying to do here is to compute the slope of a line passing through 2 given points. So let's look at an example. Suppose we want to find the slope of the line passing through the following 2 points. Let's say negative 2, 6 and 2, 3. Now, generally what I do is I designate one of these ordered pairs to be x sub 1, y sub 1. So I write that underneath the first ordered pair. And likewise, under the second ordered pair, I'm going to write x sub 2, y sub 2. I want you to get in the habit of doing this because then you're less likely to make a mistake when you substitute those values into the formula itself. Another common mistake that students make is for some reason they like to compute the change in the x's and put that upstairs in the numerator, and that's not correct because it's the rise over the run or the vertical change over the horizontal change. So you have to compute the difference in the y coordinates upstairs and the difference in the x coordinates downstairs in the denominator. So y sub 1 here is 6 and y sub 2 is 3. X sub 1 is negative 2 and x sub 2 is 2. Be careful with your rules for sign numbers so that you will compute the slope correctly. So 6 subtract 3 is 3, and negative 2 subtract 2 is a negative 4. So the slope is equal to negative 3/4. So this is the change in the y's over the change in the x's. Now let's see what's going on geometrically, how to interpret that. So let me change colors. Let's plot these ordered pairs. Negative 2, 6 would be here, and 2, 3 would be here. So what I'm trying to do here is to compute the slope of the line that passes through those 2 points. The first thing I'm going to do geometrically here, again I'm going to change colors, is I want to compute the change in the y's divided by the change in the x's. So let's compute the vertical change first. I could go from here to here or here to here, it doesn't make any difference. So to go from this point to the other point, I have to move 1, 2, 3 units up. So that is positive 3. That is equal to the change in the y's. Now, to get from here to here, I have to go 4 units to the left. So that's -4, and that's the change in the axis. So the change in the y divided by the change in the x would be equal to 3 over -4, which is the slope. Now, I must point out here that in computing the slope, anytime you go to the right or up, then you're going in a positive direction. Anytime that you go down or left, you're going in a negative direction. So that's why here, since I'm going up, I have a vertical change of +3, and here, since I'm going to the left, I have a horizontal change of -4. Now, looking at this again, if I were going from this point to this point, then my vertical change here, or the change in y, since I'm going down, is actually equal to a -3. And my horizontal change, since I'm going to the right, is actually equal to +4. But when you compute the change in the y over the change in the x, you'll still come up with -3/4. So here, the change in the y over the change in the x, change in the y would be -3. The change in y would be equal to -3, and the change in the x would be +4. Either way, that's still equal to -3/4. Again, we're computing the slope of the line that passes through 2 points using our formula. So we're going to designate the first ordered pair here as x1, y1, and the second ordered pair as x2, y2. And we're going to use the formula m is equal to y1 minus y2 all over x1 minus x2. Again, I must caution you that it is the change in the y's divided by the change in the x's. So we've designated this ordered pair to be x1, y1. So y1 is 2. y2 is 14 over x1, which is -1, minus x2, which is 5. So we have 2 subtract 14, which is -12, and -1 subtract 5 is -6. So it gives us -12 over -6, which is actually +2. So the slope of the line passing through the ordered pair -1, 2, and 5, 14 is actually +2. We're still working with slope. This time we find the slope of the line passing through the ordered pair 3, 2, and -6, 2. Again, I'm going to designate one of the ordered pairs as being x1, y1, and the other ordered pair as being x2, y2. And using my formula, the slope is equal to the vertical change over the horizontal change, so that's y1 minus y2, all over x1 minus x2. So x1 here, or y1, is 2 minus y2, which is also 2, all over x1, which is 3, subtract x2, which is -6. So I have 2 minus 2, which is 0, And 3 subtract negative 6 is actually positive 9. 0 over 9 is 0. So let's take a look at what's going on geometrically here in reference to these 2 points. So let's plot these ordered pairs on the number lines. I have 3, 2. And I have negative 6, 2. So if I connect these 2 points, you see there, I actually have a horizontal line. And horizontal lines have slope of 0. Previously, we have found the slope of a horizontal line. We found that the slope of a horizontal line was equal to 0. So let's look at another example where I asked you to find the slope of the line that passes through 2 points. In this particular case, we're finding the slope of the line that passes through the ordered pair 3, 4, and 3, negative 2. Again, like I have done in the previous examples, I will designate one of these ordered pairs to be x sub 1, y sub 1, and the other ordered pair to be x sub 2, y sub 2. And then I'm going to compute the rise over the run, or the vertical change divided by the horizontal change, which is y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So y sub 1 here is 4 minus y sub 2, which is a negative 2, all over x sub 1, which is 3, minus x sub 2, which is 3. So that gives me 6 over 0. Now, anytime you have 0 downstairs, then your fraction is undefined, which means that there is no slope. No slope and 0 slope are not the same. No slope means that the slope is undefined, whereas 0 slope is just that, the slope is equal to 0. So let's look at what's happening here geometrically by plotting these 2 ordered pairs. So let's plot the ordered pair 3, 4. 3, 4, and 3, negative 2. Now if I draw the line that connects these 2 ordered pairs, we'll see that that line is a vertical line. And vertical lines have no slope. That is to say, the slope is undefined. Previously we discussed finding the slope of a line that passes through 2 points. Now we're going to look at the equation of a line. And the first formula that we're going to take a look at is called the slope-y-intercept form of the equation of a line. And it's written in the form y is equal to mx plus b, where m represents the slope of the line and b is the y-intercept. If you recall from our previous discussions, the y-intercept is the y-coordinate of the point at which the graph crosses the y-axis. So the coordinates of that point at which it crosses the y-axis here would be 0, b. So how do you write an equation in the slope y-intercept form? For example, suppose that I give you the following equation, and I want you to find the slope of the following line and also the y-intercept of 2x plus 3y equal to 12. Now, what I need to do is somehow I need to transpose this equation so that it is in the form y is equal to mx plus b. So what does that mean? That means I need to solve for y. So I need to isolate y on one side of the equation and get everything else on the other side. So in order to do that, I'm going to have to subtract 2x from both sides. So that's 3y is equal to minus 2x plus 12. Well, I'm not quite there. Here the coefficient for y is 3, and I want the coefficient for y to simply be 1. I want 1y, or simply y, positive 1 times y. So that means that I now need to divide both sides of the equation by 3. So I get y is equal to minus 2/3 x, and of course 12 divided by 3 is 4. So now the equation is in the form y is equal to mx plus b. So I can identify the slope. The slope here is m. So m is equal to negative 2/3. And this is the y-intercept. So the y-intercept here, b, is equal to 4. Now that also gives me another way in which I can graph this particular equation. I know the y-intercept. The y-intercept here is 4. So that means that the graph of this particular function crosses the y-axis at 0, 4. So I know that 0, 4 is a point on the line. Now I know the slope here is equal to negative 2/3. So my slope, m, which is equal to negative 2/3. And remember what the slope is. It's the change in the y's over the change in the axis. So I have a vertical change here of minus 2. So I need to go down 2 units. And I have a horizontal change of 3. So if I go over 3 units, that gives me another point on the graph of this particular function. So 2 points determine a line. So if I draw a line through those 2 points, I have the graph of the equation 2x plus 3y equal to 12. Still working with the slope y-intercept form of the equation of a line. And this time we want to take 6x minus 3y equal to 21 and express it in this slope y-intercept form. So what we have to do is write this equation in the form y is equal to mx plus b. So that means that we have to solve for y. So we have 6x minus 3y equal to 21. So I need to remove the x from the left side so I can isolate the y. So I'm going to have to subtract 6x from both sides. So if I subtract 6x from this side, the 6x and the minus 6x do each other in, leaves me with minus 3y. And if I subtract 6x from this side, I have minus 6x plus 21. I haven't quite solved for y. I want y, or positive 1 times y. So in order to achieve that, what I'm going to have to do is divide both sides by negative 3. So I divide everybody by negative 3. So that gives me y is equal to negative 6 divided by negative 3 is positive 2. So that gives me 2x minus 7. So now I have the equation in the form y is equal to mx plus b. So my slope here is 2. So m is equal to 2, or if you like, 2 over 1. And my y-intercept here is negative 7. So b is equal to negative 7. So that gives me an ordered pair on the graph here. Remember that, again, the y-intercept is the y-coordinate at which the graph crosses the y-axis, the y-coordinate at which the graph crosses the y-axis. So here I have the y-intercept is -7, so it crosses the y-axis at 0, -7. Now, what I need to do here is to find another point on the line. It takes 2 points to determine a line. So what I'm going to do is I'm going to look at the slope. And by definition, the slope is equal to the change in the y's over the change in the x's. Here, the slope is equal to positive 2, or 2 over 1. So I have a vertical change of 2. So I need to go up 2 units. And I have a horizontal change of 1. So this point here, which has coordinates of 1 and -5, is also on the line 6x minus 3y is equal to 21. So I have this point, and I have this point. So I connect these 2 points with a straight line, and that gives me the graph of the equation 6x minus 3y is equal to 21, or equivalently, y is equal to 2x minus 7. We've discussed the slope y-intercept form of the equation of the line. Now we want to talk about a different form of the equation of a straight line. It's called the point-slope form of the equation of a line. The equation of a line with slope m that passes through a point x sub 1 y sub 1 is given by the formula y minus y sub 1 is equal to m, which is the slope, times the quantity x minus x sub 1. And again, x sub 1 y sub 1 is a point on the line, and m is the slope of the line. So let's find the equation of a line giving a point through which it passes and the slope of the line. So let's find the equation of the line passing through the ordered pair 8, 10 with slope m equal to 3/2. So here I've given a point on the line and the slope. So in order to write the equation of that line, I'm going to use the point-slope form of the equation. Just as the name implies, I have a point through which the line passes, an ordered pair, 8, 10, and I also have the slope of that particular line, which is 3/2. So I'm going to simply substitute those values into the point-slope form of the equation of the line, which is y minus y sub 1 equals m times x minus x sub 1. So that's y minus y sub 1. Now this is x sub 1, and this is y sub 1. So y sub 1 is 10, so that's y minus 10. M, which is the slope, is equal to 3/2 times the quantity x minus x sub 1, which is 8. So I have y minus 10 is equal to 3/2 x, and I've got to distribute my 3/2, so I multiply everybody inside parentheses by 3/2. And of course here I can do some cancellations to make things a little easier. So continuing over here, that gives me y minus 10 is equal to 3/2 x minus 12. And if I add 10 to both sides, I'll have it in the slope y-intercept form. I add 10 to this side, the minus 10 and the 10 will do each other in, and that gives me 3/2 x. If I add 10 to this side, then I have minus 12 plus 10, which is actually equal to a minus 2. So here I have the equation of the line written in the slope y-intercept form as the final answer. but I had used the point-slope form of the equation of a line to derive this particular equation here. Now, the standard form of an equation of a straight line is ax plus b equal to c, where a, b, and c all are integers. Now, in this particular case, this is written in the slope y-intercept form. This is the standard form. So if I want to transpose the slope y-intercept form of the equation into standard form, then the coefficient for x has to be an integer, and here it is a rational number, or actually a fraction, and the coefficient for y has to be an integer, and c as well. So if I want to write this in standard form, then I need to get rid of the fraction. So what I need to do here is to multiply everybody by 2. So that would be 2y is equal to 2 times 3 halves x minus 2 times 2. I'm multiplying everything through by 2. So that gives me 2y is equal to, here the 2's will cancel, 3x minus 4. Now it's not quite in the form ax plus by equals c. I want the x term followed by the y term is equal to the constant term. So I need to transpose this to the opposite side. So if I do that, that gives me minus 3x plus 2y equal to negative 4. And in general, I like for the coefficient for my x term to be positive. So what I would now do is multiply this through by negative 1. So if I did that, that would give me 3x minus 2y is equal to positive 4. We're still writing the equations of lines, and we have two formulas which we're going to use. We discussed both of them. One is the slope y-intercept, and the other one is called the point-slope form of the equation of a line. Here I'm asking you to write the equation of the line that passes through the points negative 1, 2, and 5, 14. Well, I have a point through which the line passes. In fact, I have 2 points through which the line passes. I don't know the y-intercept, so I'm not going to use the slope y-intercept form. So what I want to do is use the point-slope form of the equation of the line, because I do have a point through which the line passes. However, I do not have the slope, but that's not a problem here because I can compute the slope of the line here because I have 2 points through which it passes. So I'm going to use the point-slope form of the equation, which is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Well, I can designate this point to be x sub 1, y sub 1. It doesn't really matter which one you designate here to be x sub 1 or y sub 1. I could as easily designate this to be x sub 1, y sub 1. So I have a point through which it passes. I have x sub 1 and I have y sub 1, but I don't have the slope. So what I need to do first of all is compute the slope. So the slope is equal to the vertical change over the horizontal change, or the change in the y's over the change in the x's. So that's y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So y sub 1 is 2, y sub 2 is 14, and x sub 1 is negative 1, and x sub 2 is 5. So 2 subtract 14 gives me a negative 12. And negative 1 subtract 5 gives me a negative 6. So that gives me a slope of positive 2. Now I have the slope, so I can substitute that into the point slope form of the equation of a line. So I have y minus y sub 1, and y sub 1 here is 2. Now, again, I could use 14 here to be y sub 1 because the designation of x sub 1, y sub 1, and x sub 2, y sub 2 was purely arbitrarily. So I could have called this one x sub 2, y sub 2, and this x sub 1, y sub 1. So I could use either 14 or 2 here. But you must be consistent. The slope here is 2. And since I use y sub 1 here as 2, then x sub 1 is going to have to be negative 1. So that's x subtract a negative 1. So that gives me y minus 2 is equal to 2 times the quantity x plus 1. Distribute the 2. Multiply everybody in parentheses by 2. And I have y minus 2 is equal to 2x plus 2. And if I add 2 to both sides of the equation, I have y is equal to 2x plus 4. Now, if I did this correctly, I could check this because both of these ordered pairs here should satisfy this particular equation. So if I take negative 1 and plug it in for x, then that should give me a y value of 2. If I take negative 1, plug it in for x, that should give me a corresponding y value here of 2. So if x is negative 1, 2 times negative 1 is negative 2. Negative 2 plus 4 gives you a y value of 2. Likewise, if I take 5 and plug it in for x here, then that should give me a corresponding y value of 14. So plugging 5 in for x, 2 times 5 is 10, plus 4 is 14. So it checks out. So both of these ordered pairs should work in this equation. If that is not the case, then you've made a mistake somewhere along the way. Again, we're still writing the equation of lines here, and we want to write the equation of the line passing through the 2 points 4, negative 2, and negative 8, negative 2. Again, we have two equations which we can use to write the equation of lines, and or two formulas to write the equation of line, and that's the point slope and the slope y-intercept. In order to use the slope y-intercept, then I need to know the slope and the y-intercept. Now here I don't have the slope of the y-intercept, but I do have a point through which the line passes. In fact, I have 2 points through which the line passes. So it makes sense to use the point slope because I do have a point through which the line passes. And I can find the slope given that I have 2 points on the line. So the first thing I'm going to do is compute the slope. So m is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So again, designate one of these as x sub 1, y sub 1, and designate the other as x sub 2, y sub 2. And compute the slope. So I have y sub 1, which is negative 2, subtract y sub 2, which is a negative 2, all over x sub 1, which is 4, minus x sub 2, which is a negative 8. Be careful with your signs here. I have negative 2, and if I change the subtraction to addition, change the sign of the number being subtracted, that's negative 2 plus 2, which is actually 0. And 4 subtracted negative 8 is 12, which actually gives me a slope of 0. Now, again, what I'm going to do is I'm going to use the point slope form of the equation of the line because I have a point and I have computed the slope of the line. So I have y minus y sub 1. Y sub 1 is a negative 2. Be careful with those double negatives. M is 0. 0 times the quantity x minus x sub 1, and x sub 1 is 4. So it gives me y plus 2 is equal to 0 times anything is 0. So that's simply y plus 2 is equal to 0, or if you like, y is equal to negative 2 if we subtract 2 from both sides of the equation. And if we were to look at the graph here, we would see that this is actually a horizontal line. I have 4, negative 2, and I have negative 8, which would be out here somewhere, negative 2, and you see that's a horizontal line. Well, we know that a horizontal line has slope equal to 0. We learned that earlier, that a horizontal line has slope equal to 0. Now, here I don't actually have to use this formula because I know that the slope is equal to 0. Horizontal line has slope equal to 0. The equation of a horizontal line will always be y is equal to some constant. So what is y equal to here? Look at your ordered pairs. This is a dead giveaway. Both of your y coordinates are equal to negative 2. So the equation here is y is equal to negative 2. And here I will simply allow you to bypass the computational stage here if you realize that since both of the y coordinates are the same, that I have a horizontal line and that the equation of a horizontal line is equal to y is equal to some constant. Notice that here your y coordinates are constant. They do not change. Y here in the first order pair is negative 2. Y in the second order pair is negative 2. So the equation of the line is y is equal to negative 2. Again, we're asked to write the equation of the line passing through the 2 points 3, negative 6, and 3, 4. And again, I've got to decide whether I'm going to use the point slope formula or the slope y-intercept. I can compute the slope here, but I do not have the y-intercept. But I do have a point through which the line passes. In fact, I have 2 points through which the line passes. So I'm going to use the point slope form of the equation of this line. But the first thing I need to do is to compute the slope. So the slope is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So again, I'm going to come up under each ordered pair and I'm going to designate one as x sub 1 y sub 1 and the other as x sub 2 y sub 2, and I'm going to compute the slope. So y sub 1 is negative 6 minus y sub 2, which is 4, all over x sub 1, which is 3, minus x sub 2, which is 3. So minus 6 minus 4 is negative 10 over 0. Now, do not get zero slope and no slope confused. If you have 0 downstairs, that means that the slope is undefined. That means that there is no slope. No slope and zero slope are not the same thing. Now, recall earlier we said that vertical lines have no slope, or a slope which is undefined. And this is a vertical line. If we plot these ordered pairs, we have 3, negative 6, which is this point, and we have 3, 4, which is this point. And if we draw line that connects those 2 points, you see that it is a vertical line, and vertical lines have no slope. Now, since the vertical line has no slope, we cannot use the formula y minus y sub 1 is equal to m times the quantity x minus x sub 1, because here the slope is undefined. So we cannot use this particular formula. So what is the equation? Well, if it's a vertical line has the equation x is equal to some constant. So what is x equal to here? Notice that in each case x is equal to 3. X is a constant. It doesn't vary. X is always going to be equal to 3. So the equation of a vertical line is x equal to some constant. Look at the two x coordinates. They are the same. So you know that x is equal to 3. Again, if you notice that the two x coordinates are the same, and I ask you to write the equation of the line passing through those 2 points, you can bypass all this computation here and simply write x is equal to 3 or whatever the two x coordinates happen to be if they are the same.